Hello, hello. Are we live? Not yet. Come on. I bet we're probably live. Just give me a second to confirm. Looks like it. There we are. Okay. So, welcome back to the Advent of Sintran 2024. Today is day 12. So, let me download my inputs. Let's see what that input looks like. A bunch of letters. Lots of U's, K's. Not another word search, probably. Unless... So it's 140 by 140. It's a square grid. Alright, let's read the puzzle input. Garden plots. Is this my example input? Then we have a larger example. I think I want the larger example. So 10 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. It's 10 by 10. Garden plots. Fences. All right, so different letters are different plants. So what is a region? I guess A's are a region. Contiguous B's are a region. We have to figure out how much fencing we need. And that depends on the area and the perimeter. Alright, what the hell is going on with my USB thing? This is annoying. Please stop making noise. Well, in case you had any doubt about how to calculate perimeter, they make that pretty clear. All right, and here's the same thing, but broken up, just to make it visually clear. All right, and you can have enclaves and exclaves, if that helps you. 5 regions. So this counts as 4 separate X regions, not like one discontiguous X region. And then we're summing the product of the perimeters and areas. R. How does this work? Do we have any duplicates here? R, I. Okay, so we have two different I regions here. And if I highlight that, it makes it clear we have an I region up there and another I region down there. So those count as two separate regions. So this is a good example. I think it covers all the cases. And the exterior perimeter, like on the boundary of the entire map, that also just counts as regular perimeter, right? I hope so. So this is the I region with area 4 and perimeter 8, and then the lower one, 14. Should I count these manually? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I think I counted that correctly. Okay, so I think I understand area and perimeter. Yeah, area is easy. We're going to flood fill. It's going to be like a breadth first or a depth first search. Either one would work, just like, was that 2 or 3 days ago where we were doing searching on a height map? Now we're just searching for regions of the same letter. So it's the same searching idea. Area is easy. It's just the number of grid positions that you visit. Perimeter is, it might be slightly tricky, but it shouldn't be hard. Basically, like if you have a block, it's going to have a perimeter of 4, and then for each neighbor that it has, you subtract 1. So this block would have 4, but it only has a perimeter of 3 that it contributes because it has 1 adjacent neighbor above it. Diagonals don't count. We're just going up, down, left, and right. Do they say anything about diagonals? They don't, but up, up, down, south. No, they don't explicitly they don't explicitly say anything about diagonals, but I don't think they count. All right. This doesn't sound too bad. Who knows what's coming in part 2? That might be tricky, but part 1 is not bad. Maybe part 2, though, odd diagonals or something. Although I doubt it, because you'd think they would explicitly say that diagonals aren't allowed in part 1, unless I missed that. Neighbors? Yeah. No word. I think I need to turn my volume down. Sorry about that. Okay, this is day 11. Here's my template. My template should be able to just read the test input. And there it is. That's the test input. So we're going to iterate square by square. And we're going to need like 2 different Boolean matrices. We're going to need one to mark like the current region, and then we're going to need another one to prevent us from researching things that we've already mapped out before. So if we do all the R's, then we've basically covered the first 4 grid points, grid elements, grid entries, whatever you want to call them. We've covered all 4 of these. So then as we're iterating in reading order, when we get to this, we've already done R. We don't want to search all of those R's again. So it's going to be a little bit different from the search problem from 2 or 3 days ago. I'm going to want to save this entire grid. Actually, which day was that? Was that 10? I feel like it was 2 days ago. We had directions. Yeah, this was... Let me just steal some of my code from 2 days ago here. Order of the directions doesn't matter. Not like that clockwise guard turning right problem from almost a week ago, whenever that one was. And then I want to steal most of part 1, or the parsing part of part 1 at least, from 2 days ago. Except it's not heights, and it's not integers. It's going to be a string. I'm just going to call it chars. I don't care about vegetables or plants or whatever the fuck is in this plot. So chars. It's not parsing, it's just a string directly, so we don't need to cast that at all. And that should echo my grid as a matrix of strings or a matrix of characters. Really, they're strings, but they all have length 1, so I'm going to pretend that they're characters. I don't have separate character and string types in my language. I only have a string type. Okay, so we're going to want 2 different visited Boolean arrays. False nx by ny. And then we're going to have another one like that, but I'm going to call it ever visited. Maybe that makes sense. So this one, we're going to update it on like every iteration. Or we're going to reinitialize all of it to false on every iteration. This one, we're just going to toggle things to true, and we're never going to set them back to false. Once they become true, they're going to stay true for the rest of part 1, basically forever. So we're going to iterate through the map with a double spatial loop. And if we've ever visited this point, we're going to skip it. Ever visited XY. Continue. Okay. Then let's remember to update that at the end. I should just be able to do the entire array like that. And then we're going to reset this to false, the whole array. And then we're going to do a search. So I'm going to have a stack, and I'm going to have a stack pointer. I'm not going to use a queue. Stacks are easier because there's only one end of the stack that you need to keep track of. And I guess the stack is kind of like two-dimensional. It's going to be integers to keep track of like two-dimensional grid positions. And its size is going to be 2 by the worst case scenario, nx times ny. That's the maximum number of points that we'll ever have to push to the stack, and this is because it's two-dimensional. Yeah, and then we're going to have a stack pointer. Stack pointer. I think that's the same way I named it a couple days ago. Or it's like an index into the stack. So we're going to push the current location and then pop it off and start searching in like a depth first order. So we're going to push stack. It's going to be x, y, and increment that. Why not just steal from steal from 2 days ago? So I wrote this without Googling anything 2 days ago, so what's the point of doing it without a reference now? So that's kind of like our ever visited condition. So we have something that we just skip all the time. And yeah, I guess we're going to need areas and perimeters. Actually, let me get that line too. Okay. I think I want to rename these variables. Maybe I should have just written this from scratch. So I'm not satisfied with the variable names that I picked 2 days ago. Do I ever have... Yeah, so the problem is that the good single letter variable names are being used in this outer loop. And except for there and there, I basically never use them. So these are going to become x naught and y naught. They're like the initial position that you're starting the search from. And then the things that we pop off the stack, those are going to get the good variable names because we use those more frequently. Like, look at all these xs's and ys's. Okay, what am I doing? Y. There we go. Did that matter? Not really. The old variable names were fine. So I'm going to want, before I start this search, I'm going to want to initialize area and perimeter. So we have visited. Pop from the stack. We don't revisit locations multiple times. Okay, so when we do that, when we set visited, that's where I want to add to my area. Basically, wherever you do this, that's the right place to increment the area. You don't want to do it before this continue statement or too much later. Like you probably don't want to do it inside this loop where it's not anywhere near the visited guard. This is some random shit from 2 days ago, so I don't need that. And then what is the visited condition? So inbounds is good. We always want a bounds check. And then instead of a height condition, we're just going to check if we're on the same character that we started the search from. So I actually want to save that in a variable. Let char equal chars x naught y naught. That's the character that we start the search from. And we're only going to want to continue the search on characters that match this character. So if chars x neighbor y neighbor not equal char, then we skip that iteration with a continue. Yeah, and then we push it onto the stack. And then there's something else we need to do here. So the perimeter, should I just check if I get the areas correct? I want to write this while I'm thinking about it. So each point will add 4 to the perimeter, because if you think about one grid location by itself, it has a perimeter of 4. So every time we add 1, we're pushing a perimeter of 4 to it. And then we're going to subtract to account for like the neighbors that it has. Like these two eyes are next to each other. So if you think about the rightmost eye, it would have a perimeter of 4, but because there's one next to it, we subtract 1 and we make it 3. So actually for each neighbor eye that this eye has, we're going to subtract 1 from that initial perimeter of 4. And we can do that inside this neighbor check before we do any continues. Actually, we have to do it after the bounds check, because you don't want to check things that are out of bounds. And then I should be able to do something like, I can just put it right here because it's exactly this condition. So if they're not, if the characters don't match, you still want to add to the perimeter. But if they do match and you make it past the continue, then perimeter actually minus equals 1, because 2 neighbors share 1 edge. So we subtract 1 here, but then 1 point by itself has a perimeter of 4. So we add 4 and then we subtract 1. And I think that should work. And then the sum is just the area times the perimeter. That might be it. Does this print? This doesn't print anything, does it? Because I deleted that before I pasted in the stuff from 2 days ago. This probably won't compile. Let's find out. 1930. That was easy. Let's do the real input. I don't even need to print out the individual areas and perimeters. I just got all that on the first try. So there's that. And my code even was free of syntax errors on the first try. So that's an accomplishment. All right, part 2. Number of sides. What the hell does that mean? Oh. That's less obvious to me. How do you get the number of sides? I wish they could show the larger example like right here. I mean like the map of the larger example, which is this. So if we look at the eyes, the upper eye has an area of 4 and it has 4 sides. It's not a perimeter of 8 that matters. Now what matters is that it has 4 straight sides. So is that how they count that? 4 by 4, yep. And then the other eye, this should be easier to count this time. I'm going to start from the same point in this corner. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 sides. 16. Okay, so I understand what the number of sides is. Geometrically, how do I calculate that? Man, that's tricky. It's like, it sounds like a simple enough geometric problem, but off the top of my head, I have no idea how to do this yet. 16. Don't know how much of this pane you can see. I have to wait for the stream to update on my other computer. So let's go to 12. Let's vim the test input. Okay, there are all my eyes. Maybe I should start with R since that's the first one. So if I start from the top left, I have, yeah, you can see all of that. In fact, that's way too much. Okay, so if I start from here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides in that R region. That's part 1. 10. That's 10 sides. Man, perimeter was so easy. Well, perimeter was non-trivial. I mean, I feel like I got lucky knowing how to calculate perimeter, despite never having seen that problem before. But then number of sides, that's not as easy as perimeter. I feel like you have to like physically trace it out with your algorithm. Like you have to start from a corner and then identify a side which goes in between something that's in your region and something that's in your region on the right and something that's outside the region on the left. So that identifies a segment of a side. And then you have to look around. So it's very easy to index the points or the elements. Let's have concepts of cells and points. So a cell is like the letter R, and then a point is like the point in between these 4 R's. So right in the middle of this 2x2 region, there's a point in between the 4 cells. This is like CFD terminology, if that helps you. So I think we need points and cells. We already have cells. Basically, part 1 was cells only, and you didn't have to worry about points. And then for part 2, we have to start to think about points. And then a segment of a side is, it goes between 2 points. And then I can index those as well. There's going to be one more point in every direction than cells. So this is 10 by 10 in the cells, but it's going to be 11 by 11 in points. Hey, Vision for All, welcome back to the stream. I think I saw that you were streaming earlier. Did you do today's problem yet? Part 1 was pretty easy for me, but part 2 is kind of tricky here. Do I even care about points, or do I want edges more than points? In the end, I want edges, but I think it's easiest to get to edges by starting with points, and then an edge goes between 2 points. So you want to find points that are on the boundary of the region. can I iterate these in order? It's like if I'm starting at the R, I want to find the point above and to the left of that. And if I iterate in reading order, is that always going to start me on an edge? I think it has to. I, C, F, V, R, already did R's, did C's, excuse me. E. Yeah, I think the first time I run into any region, if I go above and to the left, as long as I've processed other things before, then that's always going to be on an edge. Yeah, this is part 2. So I can find that. And then you can check if a point is on the edge if some of the surrounding cells are inside the region and some of the surrounding cells are outside the region. So if we're at this point, the V is outside and all of the R's are inside, so that means the point has to be on the edge. And then you can kind of trace out the perimeter, I think. And you want to make sure you don't start going backwards. So if you start going counterclockwise, you have to keep going counterclockwise and not start going back clockwise at any point. So that might work. Not really sure how to code that, but I bet I can do it. Man, part 1 was so easy. So let's take part 1 and copy and paste it. And this will become part 2. Okay, so we've flood filled our region, and we have the area, and we have the perimeter. Now I want the number of sides. So as you're tracing out the perimeter, somehow I got part 1 without explicitly tracing out the perimeter. There's a shortcut that I was able to take. For some people, maybe they did this like a harder way for part 1, and then part 2 is going to be not much of a difference for them. But for me, I did it the hard way. So now I'm going to have to trace out the perimeter, I think. Maybe there's some shortcut you can take for part 2. I don't know what it is. I wonder if you could like start with a bounding box around all of these R's and say that has 4 sides, and then slowly like start to carve out the V's that are inside the box and carve out the C's and like slowly update the number of sides from that. Like every region has to have at least 4 sides. So you could start with a bounding box with 4 sides and then carve out stuff. But then you have to be careful about interior regions too. Like this example doesn't have it. But yeah, there's probably some recursive algorithm that you could do for that. Like this one with the E's. You counted the angles. That is the same. Oh. I think that's it. Yeah, that does sound a lot easier than counting the sides. Yeah, so I think for part two, I want to check the diagonal neighbors too. And then that should help me count the angles. But then I also have to not double count any angles. Okay. Yeah, I think I can tackle this. So we're still going to have the visited array. And this is the cells that are visited. And then we're also going to have P visited for the points that are visited. That's going to be +1, +1. Is there any visual aid that I can use to explain this? Yeah, probably not. I don't know. So I have cells and then I have points. And I'm going to reset both of those. This is part 2, right? I don't want to accidentally edit part 1. Oh, you're so far behind. Yeah. Which days? Are you like 3 days behind? You could just do everything 3 days late. It really doesn't matter. I think I had trouble yesterday, but the other days that you missed weren't that bad. Or do day 13 tonight. Go back later. Yeah, do 10 and 11 at the end. Oh, you're sleeping when they come out. So do I. I mean, I have like a somewhat normal sleep schedule on the East Coast, so I never do these. I can't say never. I almost never do them at midnight, except sometimes on the weekend. I don't think I'm going to do that this weekend because things are probably going to start to get difficult. So we have cells and we have points. So this is going to be 2 by 2 cells. Don't worry, Mr. Jeff. Oh, yeah. Maybe I can save Christmas. I don't know. I don't think I can get all 50 stars. I've had a good track record so far, but I'm not going to get all 50. So we have 2 by 2 cells here. And then we also have actually 3 by 3 points. So there's one more cell. No, there's one more point than cells in each dimension. Quitter. I'm just not committed to it. Maybe Vision for All can save Christmas for both of us. So basically every cell, let's call this cell 1. Let me use the red color for cells. Every cell is going to have a point associated with it that's above and to the right. And then, well, I also need to get the extra ones somewhere. Yeah, so when I'm searching from cell 1, I actually have to look at all 4 points that are around it. And if we index this one, actually it shouldn't be 1. This is a 0-based programming language, so this should be cell 0. This cell, it has 1 angle. Yeah, it has 1 angle, but potentially it could have 4 angles. So we need to check all 4 points that are surrounding cell 0, and then check if it's an angle. So this one, it's on the boundary, but it's a straight line running through it, so that's not an angle. This one is inside, so that's definitely not an angle. And then this one is also a straight line. So it really only has 1 angle out of the 4 potential ones. Yeah. And cell 0 is indexed at x equals 0 and y equals 0. And then the point above and to the left is also 0, 0. So like the points are shifted a little bit off by 1. It's a classic fence post problem. It's a fence post problem, but in 2 dimensions. So then this point is going to be 1, 1. Yeah. The cell has 1 angle because the cell up and the cell to the left are different. Yeah. Do you ever get diagonals that touch? Like, let's say that I change this input a little bit. Let's say I have R's that go like this. So right here, you have kind of a weird case. It's still one contiguous region of R's, but right here you have 2 cells that touch diagonally. So I think there are 2 angles there. Cell 2, yeah, if I go back to the paint, 1, 2, well, it doesn't really matter which one you mean by cell 2 because all of them have 1 angle. Because up, and right, so cell 1, really, the second cell if you use 1-based indexing. Because up and right are different. Yeah, so I think the logic is going to boil down to exactly what you're saying. Okay. So where do I want to do this? I think I can do it before this for loop. The cell up and the right are equal and the central cell, but the cell is in diagonal between up and right is different for this case. Perimeter nang n-ang. Number of angles is the same as number of sides. And we don't care about perimeter for part 2, so I'm just going to delete that and delete this dead code from 2 days ago. There's no score either. All right. I think Vision for All, I think you're probably describing something more elegant than what I'm about to do. But I'm about to write some code that's messy. And it's going to be like a weird paraphrasing of the algorithm. Yeah, there are 8 cases. If you look at 4, if you look at a group of 4 cells basically surrounding this point, 1, 2, 4, 8. Yeah, like it's a 4-bit number, so there are 8 cases. I mean, I don't need to do this inside. Yeah, I don't need to do this inside the depth first search. I could make an aggressively large pass over the whole grid and just do this outside the search. So there's no reason to do it like this. But maybe I want to mark everything. Yeah, because I need to know what's visited. That's going to help in case you have like discontiguous R's. Like if I had more R's down here, this is actually a separate region of R's than the upper left region of R's. So you want to be careful to distinguish that. So I do have to do it after the search, but I don't have to do it inside the search loop. I can just make it like another loop that's afterwards. Let me undo all the weird edits that I've done to this. Okay, and then let's go back to the test input. Yeah, let me not initialize it up there. Let's do it after the search loop. And then instead of perimeter, this is going to be the number of angles now. Count angles after the depth first search loop above, because it's easier this way. And I'm just going to do like a brute force scan over the entire grid. It's only like a 140 by 140 grid, so that's not that bad. Already using X and Y and X naught and Y naught. Actually, X and Y are local here, but maybe I want to give them different names for clarity. So PX, it's like the point index, which is different from the cell index. So it's going to go from 0 to NX plus 1 because there's one more point than cells in each dimension. And then it's a double space loop, so there's X and Y. And then, like you said, there are 8 cases. It's going to be like the 4 surrounding visited cells. So maybe I want to pull that out. Into 4 separate variables, but I think I want to actually write a little diagram in my code here. This is probably going to be bigger than it needs to be. And then copy that. Okay. Now we have a point in the middle and we have 4 cells around it. Point PXPY is in the middle surrounded by 4 cells like this. Okay, so there's P, and then we're going to have cell 0, cell 1, cell 2, and cell 3. Okay. I think that's a good enough diagram. If I made it like 1 character wider everywhere, that might make more sense. So this is going to help me code out the 8 cases. So the number of angles at point P, let's call this P, depends on which of C0 through 4 are in the current visited region. There are 8 cases. Okay, yeah, this isn't going to be so bad. Thanks for the help, because I probably would have had a lot more trouble thinking through this by myself. All right, so every cell is going to be associated with the point above and to the left of it. You can make cell C4 to the right of C3. Oh, no, I'm looking at P in the middle. So I think C4 is not going to be related. This is not necessarily a region. Like, any one of these might be outside of the region. So P is in the middle, and that's going to have the same index as C3. So C0 is actually -1 in the X and -1 in the Y. And I'm going to need bounds checking. So that's kind of annoying. Okay, I don't want to redeclare these all the time. I should make a function. Okay, so I already have a function to check if it's in bounds though, so this is going to be less copying and pasting than it absolutely needs to be. I think I need a ternary operator in my language. So inbounds 0, 0, cx, cy, nx, ny. So if this cell is inbounds, if we're looking at like the point in the very upper left, it's going to have some cells that are out of bounds. So there needs to be a bounds check here. Let let's initialize all 4 of them. Because in the case that any of these are out of bounds, they're just going to stay false. But if it's in bounds, we just want to grab it from that visited array. Okay, and then we're going to repeat this 4 times. It really should be a function, but it really should be a function. Yeah, so C0 is there. It's -1 in both directions. C1 is going to be the same index as P and X, but then -1 in Y. So let's change that to a 0. And that's going to be C1 now. C2 and C3. That part is easy. Okay, now C2, it's -1 in X, but the same index in Y. So this becomes a 0. And then this is same index in both dimensions. Okay, I think those are the Booleans that govern our 8 cases. Yeah, I still think I'm doing this in a messy way. I might have more. 2, 4, 8. I might have 16 cases, but a lot of them are never going to happen because at least one of these points has to be in the visited region. Actually, no, because I'm iterating over everything. So sometimes I'm going to hit cases where all four of these cells are outside the region. Okay. Yeah, there are 8 cases that matter. Most of the cases we're not going to increment the number of angles at all. Then we have 4 cases. Yeah, it's exactly what you said, where one of these cells is different than the other. So I'm going to write it up here so that I can look at this diagram while I'm writing the code, and then I have to move it, obviously, after I set C0, C1, C2, and C3. You could probably do this with like XORs and ORs and some kind of crazy logic, but I think it's just easier to write the 8 cases explicitly. So if C0 and not, I'm going to do it like this, any C1, C2, C3. Basically, this means C1 or C2 or C3. So that's going to be number of angles gets incremented. Yeah, that should work. So there's that one. There are going to be 4 cases like this. We can just permute things. 2, 3, 0. It's kind of like a cross product. 3, 0, 1. 0, 1, 2. Okay, so C1, here it's on the left, but it's not on the right of this and not. Then C2, it's on the left there, but not the right. Then C3, I think those 4 cases are correct. And then the other cases, oh, yep. Have a good night. Thanks for tuning in, and thanks for the help. Yeah, I really think you helped me think through this problem. It's going to be kind of like this, but we're going to put the not here. And then this is going to be, get rid of that not, change any to all. So this means like C1 and C2 and C3. So like if this cell was in, but the other 3 were out, that would be an angle. So I think that might be it. I have no idea if this is right. I have to move this below I set those things. Then the other 8 cases, get up 2 cells on the right, 2 on the top, 2 on the left side, and 2 on the bottom. That's 4 more cases. Aren't there 16? Oh. No, I think I have the diagonal cases. There should be 8 cases. I think I have 2 more cases. Because what if C0 and what did I do there? Double backslashes. If C0 and C3 are inside and then the other 2 are outside, that should be 2 angles. And then there's another case like that where you have the other diagonal. I'm still not 100% sure how that counts, but I think this counts as 2 angles. So there are 4 cases where you have a straight edge, and then that's no angles. And then there's a case where all 4 of these cells are outside, and that's obviously no angles. Three straight edges and 3 straight edge cases and 1 case with everything outside. So in those cases, you don't need to increment this at all, so we can just do nothing. But I do have those 2 diagonal cases. So does that cover everything? We have 4, 8, 12. I still think, oh, if all 4 inside. Two cases with everything outside or everything inside. I still think I'm missing a couple cases. There should be 16 because we have like 4 booleans. So 2, 4, 8, 16. There should be 16 cases total. We have 4, 8, 12, 3 straight edge. No, there are 4 straight edges. So 12. Okay, then 2 and then 2 diagonals. Okay, yeah, that's all 16. So the diagonals are if C0 and C3 and not C1 and not C2, then we have 2 angles to increment. And then we're going to flip the knots here. So 1 and 2, and then 0 and 3. So C1 and C2. That's another diagonal case. Okay. I think those are all the cases. And there are actually 10 here that not matter, not 8. Maybe you can consolidate some of these somehow or use like fancy XOR logic. Actually, I don't know. I don't want to mess with it. I think it's more readable like this. That might be it. That doesn't compile. Well, I got part 1 on the first try, so it's only fair that I don't get part 2 on the first try. Oh, already declared. Okay. So I just have to get rid of some of these lets. And I have more problems. I never declared NAng. I thought I did that. Oh, yeah, I deleted it from up here, but then I never put it back down here. Didn't I? I initialized it after I used it. That doesn't work. Let's consolidate these comments. All right, got a good feeling about this. 1206, is that what we're expecting for the bulk discount? Man, that took some thinking. I thought I was smart with part 1, and then part 2 made me feel stupid. So does that work on the real input? It takes a little bit. Why does that take so long? I don't think that's good. Let's log. Well, I'm iterating these in the wrong order. Might be more efficient to do it like that. Then let's print some progress. Should really not be so slow. Part 1 was totally fast enough. What? Oh, it scans the entire grid for every... I think we can optimize here. So I don't want to print there, actually. I would like to print... Let's just print once up here. That's going to be slightly less verbose. Now let's print the Y's. I think we can optimize this with some well-placed continues. That's pretty slow. It's doing the first row. Okay, it got through like several rows, and there are 140, if I remember correctly. Yep, 140. So I think we can optimize this by checking if we've visited anything. So after, not there, but here, if we haven't visited anything, then we can skip the side counting. So if not any visited, continue. I think that should work. And we're like halfway, almost halfway. We're like a third of the way through already. So it won't take forever. Is that not? It's not any faster. Let me make sure I'm still getting the right answer for the test input, and then I'm just going to let it run. 1206, I think that didn't change. Okay, yeah, I'm just going to let this run. I did not expect it to be... I am kind of brute forcing here. What you could do is iterate only through the points that are in the bounding box of the visited region. So that's another optimization that you could take. While this is running, I'm going to get another water, so I'll be right back. Over a third of the way through, and that's halfway through, I think. So that's not too long. What is this going to be, like 2 minutes, maybe 3 minutes? And it's not like a uniform speed either. I don't know why that is. You have to be careful about the cell versus point fence post error. +1 appropriately. It's hard to spell. Of the visited region. There are actually 10 cases with angles. 1 or 2 angles. And it's done. Yeah, less than 2 minutes. It's not bad. I've got a good feeling about this. Okay. I was kind of worried about like those diagonal cases, the last 2 cases that I added, where you have 2 angles, not just one. These 2 cases, because like in the larger example that they give you, I don't know if it covers any of those. It's easier for me to look at Vim than to look at this, because I can Control F here, but then like the browser scrolls up to the top unless I very carefully click. So they probably happen in the real input, or you never know. Maybe these inputs are carefully crafted so that you never get those cases. So R's don't do it, I's don't do it, C's. It's close. First of all, these are 2 separate regions. And then there's actually, there's a gap of 1 still. There's no diagonal neighboring here. F, nope. R, I can't remember which letters I've done and which ones I haven't. I don't think... I could just print it out in the code to see if it ever happens. Any A's? I kind of don't want to look at all of these. I think I want to print it out in the code to see if this case ever happens. B's. So this is interesting because this has like an exclave or enclave, whichever one that is. I get them mixed up. But I think it still doesn't have a diagonal case. So I don't know how much I zoomed out. I think I usually zoom so that I have about 30 lines of code in my window. That's 30. That's 31, actually. That's 30, but kind of looks a little small. I think... I have no idea which zoom I was at. Is that saved in my Alacrity config? I'm not really sure. I think not. I know the opacity is in there. I'm not sure about the font size. Still looks small, and it looks like not rectangular. Okay, I think that maybe this is the zoom level that I had. Yeah. Okay, so we'll have a little print there. And then let's get rid of this progress. So that should run a little cleaner. And then if we have a diagonal case, it will be obvious. Let's give that 2 minutes, I guess. Okay. We do have diagonal cases, and I wonder which letter that is. So I can print the character, and then I should be able to look at that. I'll have to zoom out again. Maybe I'll just do it in my browser. That's easier. And everybody's input is different. So whichever diagonal cases I get, you will not necessarily get. Okay, Z's and S's. So where... Again, I think these are two different regions, right? Right here. So there is a diagonal neighbor, but they're two different regions. So that one shouldn't count. If I understand the neighbor rules correctly. Okay, this one has it though. On the left, there we go, I'm selecting one region. So right here, there's a Z cell. I can zoom in now. Nope, no, I can't have the line wrapping. That's what I want to avoid. So there are some points that have a diagonal edge. Yeah, I guess if you think about angles, it might seem ambiguous, but if you think about sides, it's pretty unambiguous, and apparently I just counted it correctly. It does seem like two angles, so it's also a contribution of two sides. Yeah. I think... I can't really comment that out easily. I can break up the lines. This is a good case for the C-style comments, but I do not have those in Syntran. So I think I just have to delete this. And does this still run? Was that the right answer? 838988? 838988. Now I'm zoomed in too far here. Let me clean up the grid logging too. Okay, that should only print the answers now and like some header information. Let me fix the day. This is day 12. Okay, there we go. Logging day 12, and it should only print the answer. I might not wait for that. Yeah, I'm just gonna kill that. I'm working on some dictionaries to optimize yesterday's problem. I did eventually get part 2. I had to look at other people's code before I figured it out, and I had to look at lots of people's code because almost everybody for day 11, they used a dictionary and they used recursion. And those are both things that are basically impossible in Syntran. I can kind of hack together dictionaries by doing it with arrays in a really slow implementation that scans the entire array to look up and insert. And sometimes I can do recursion by translating it to a stack-based iterative algorithm or a queue-based iterative algorithm. The dictionary part was not so bad because I can hack that together, but I have a harder time converting recursive algorithms to iterative algorithms. So I couldn't really figure out how to apply most people's code in Syntran. But then I saw some people who used something called a collection counter in Python. So I did something kind of like that. And I had like a bad dictionary type to work as a collection counter. And now I'm working on like an actual dictionary with hash maps. So just for fun to see if I can make day 11 a little bit faster. Maybe I can demo that actually. So right now it runs in like 30 seconds, a little bit less. That's better than day 12 here. And I'm not even sure what to optimize really in day 12. I guess we have the bounding box thing, but that's about it. But even with a bad dictionary, I'm getting day 11 in a reasonable time. should only be, yeah, less than 30 seconds. And that is the correct answer for my part 2. Do I have 11 open? Here we go. So part 2, I have this little function that does all the work. It's add count. It like increments a count inside my dictionary. And the vector value is the key. And then this is how much you're incrementing the count by that key. The key optimization here is that you have a lot of duplicate values in day 11. So this treats all of the duplicate values as 1. And then if you had like a count of 2 duplicates, then you would increment the count for the next iteration of that number by the count of duplicates. So that's the reason that this works. And it's pretty good. So without recursion and without actual dynamic programming, it still runs in under 30 seconds, even with a really bad dictionary. But it's a terrible dictionary, so I want to see if I can improve that. So right now, the way that it works is it scans through all of your keys, and then if it finds your keys, it increments it, and then it can return early. If it doesn't find your key, then it has to append it to the end and then increment the number of keys. So there are a lot of duplicate values. If I print n keys at the end, this is actually not a huge number. I guess I'm not really printing it anywhere. Yeah, but n keys was like 4,000 for me. So there are a lot of duplicate values, and you kind of keep getting the same values over and over again. So because that doesn't really explode, this just works, and it's not terribly slow. Anyway, that's yesterday. Let's get today committed here. Did I add everything? I don't want to add my log files or my backup versions. So I did commit part 2 there from yesterday, eventually. I couldn't figure it out on stream, but after cheating by looking at other people's code, we got there eventually. All right, that's day 12. Let me make sure that I committed or pushed. That's the thing that I want to confirm. And there's my code. Yeah, it's sort of a standard direction encoding, and then a depth first search, very similar to what we did 2 days ago. There's this ever visited array that we also did. I don't have to talk about this. You just watched me write it. So what's the point of going over it again? I think I might want to edit this grid to make it a little bit more readable so you can tell which point P is. So let's add one more of these up there and down there. And then let's add some spaces there and there. Let's move this down and to the right. C3. I'll just leave it there. Okay, so P is right here. It's this point. Point P, it's the asterisk in the diagram. So it's not the stars. And then the cells are in the middle. The point is at like a corner, an intersection of 2 edges, and then the cells are in the middle. And the cells are the actual letters in the input. In case the differentiation between cells and points is not clear, I'm just adding that comment to do my best at explaining it. Yeah, that's it. I've got 24 stars so far. I've got No viewers, so I'm not going to bother rating anybody. All right. I think that's it for today. Thanks to anybody who tuned in. I really appreciate it. And I will catch you next time. Bye.